Welcome to the Deep Dive. Today, we're aiming to give you a sort of fast-track understanding remote databases, why we need them, basically, and we'll look at Firebase as one, well, quite elegant solution.
Absolutely. The document really lays out a core problem, doesn't it? How do you manage app data when users just expect it to be everywhere on all their devices?
Exactly.
So our goal here is really to pull out the essential stuff, give everyone a clear picture of why remote databases are, well, pretty much essential now, and how things like Firebase make it, easier.
Okay, let's get right to the heart of it then. The document, it kicks off by talking about local databases, right? Like Skullite, the ones that just live on your phone or tablet. And the main point is they're stuck there, tied to that one device. So if you use a fitness app on your phone, track everything. What happens when you get a new tablet and install the same app?
Yeah, that's the crux of the issue, isn't it? And the document spells it out. Your workout history from the phone, it just doesn't magically show up on the tablet.
Right.
Each device has its own little data island. And that's, frankly, frustrating for people. We expect our info to follow us around now.
You mentioned a grocery list earlier, started on your phone, want to add things from your laptop.
Exactly. With only local storage, that seamless flow, it just doesn't happen without extra work.
Right. And it's not only about one person's different gadgets. The document also brings up sharing data, doesn't it, between different users?
Oh, definitely. That's another huge reason for remote databases. Think about a shared to-do list for a team.
Yeah, or a game, a multiplayer game.
Precisely. If you need multiple people on different phones or computers all looking at and changing the same information, well, a local database just can't do that. You need that central hub.
A shared place.
A shared repository, where everyone can read and write the data.
So, okay, before things like Firebase, how do developers handle this? Needing that central storage. The document mentions the more traditional ways.
Well, the initial approach, the sort of classic way, was setting up your own database on a server.
Like a big central computer somewhere.
Right. And then you had to build a way for the apps on phones or whatever to talk to that server. Usually that meant creating a web service.
Okay.
Technologies like REST or SOAP, they basically act as middlemen. They define how the app asks for data and how it sends changes back to that central database.
So the app sends a message, the web service does something with the database on the server, and sends a response back. Makes sense.
Yeah.
But then the document points out a big catch with that. Keeping everyone's app synchronized, up to date.
That's the tricky part with that older model. There's a delay, right? If I change something, maybe I complete a task on our shared list. You wouldn't see that change until your app specifically asked the server, hey, anything new?
So my app would have to keep checking, polling the server.
Yeah, maybe checking every minute or every few seconds, which isn't very efficient, and the data isn't truly live. There's always that potential lag.
And this is where real-time database enters the scene, as the document puts it. It defines it as using real-time processing for constantly changing data. Sounds, well, faster.
Much faster. It flips the model. Instead of the app asking, the database pushes the changes out to all connected apps the moment they happen. No more constant checking. The update just arrives. And the document gives some really good examples where this is vital.
Like what?
Well, things like accounting, you need that financial picture right now.
Right.
Banking, obviously.
Instant transactions.
Exactly. Medical systems, multimedia, process control in factories, reservation systems.
Like bookings, hotel rooms.
Right. And scientific data analysis.
Right.
Basically, anywhere that having the absolute latest information, like right this second, is critical. Think about accounting again. Real-time updates prevent errors, give you the true state of things immediately.
Okay, so that sets the stage nicely for Firebase real-time database. The document calls it a cloud-hosted real-time database. Let's unpack cloud-hosted. What's that mean practically for a developer?
It means you don't have to manage the servers yourself. Google, in this case, handles all the back-end infrastructure.
The hardware, the maintenance, making sure it can handle lots of users, scalability.
Exactly. Scalability, reliability, all that stuff. You, the developer, can just focus on building your app and using the database service rather than becoming a server admin. Its backend is a service.
Got it. And the data format in Firebase is JSON, the document says. Why is JSON important here?
JSON JavaScript object notation is just a very standard, lightweight way to structure data. It uses key value pairs, kind of like a dictionary or a simple filing system.
Human readable too, right?
Yeah, pretty easy to read. And crucially, almost every platform and language understands it easily. So it's great for exchanging data between, say, an Android app, an iOS app, and a web app. It's just efficient.
Okay. Now, The killer feature seems to be this real-time synchronization. How does that actually play out for the user?
It's pretty cool, actually. Every app connected to the database, phone, tablet, web browser, doesn't matter, is essentially looking at the same live instance of the data.
One single source of truth.
Kind of, yeah. And when someone changes data in that central instance, Firebase automatically broadcasts or pushes that change out to every connected app.
Instantly.
Almost instantly. We're talking milliseconds often. So user A updates that shared to-do list on their phone.
User B sees that update on their tablet right away.
Exactly. Without user B's app having to do anything special, like hitting refresh, it just happens.
That sounds way better. Much smoother. Okay, the document lists key characteristics. Real time, we've covered that. Then offline. That seems really important for mobile apps, right? Connectivity isn't always guaranteed.
Yeah, offline is a big one. The document doesn't go deep into how it works, but it's a key feature. Firebase SDKs usually cache data locally on the device.
So the app can still work even if you lose internet.
Right. You can often still view data and even make changes while offline. Then, when the connection comes back,
it syncs up automatically.
Generally, yes.
Yeah.
The SDK handles synchronizing the offline changes back to the server. It's a huge plus for mobile usability.
And the third characteristic, data accessible on any device, which, like you said, circles right back to the problem with local-only storage.
Exactly. Because the master copy is in the cloud and it syncs everywhere, your data follows you across devices seamlessly. Log in, and your stuff is there.
The document also throws in a little history tidbit. Firebase started out from a chat API called Involve back in 2011.
Yeah, kind of interesting, isn't it? Shows how tech evolves. They built something for real-time chat.
And realized the core tech that real-time data sync was useful for way more than just chat.
Precisely. That underlying mechanism became the foundation for the real-time database.
Then it mentions core Firebase services, highlighting real-time database and authentication. Authentication seems pretty vital if your database is in the cloud, right?
Oh, absolutely crucial. You can't just have a database open to the world. Authentication is how you verify who the user is.
Make sure they are who they say they are.
Right. And control what data they're allowed to see or change. Firebase authentication integrates really smoothly with the database, making it easier for developers to lock things down properly.
Okay, let's shift to the practical side. The document walks through using Firebase in, say, Android Studio. It starts with tools and a Firebase. That sounds like it's built right into the IDE.
It is, yeah. Most modern IDEs, like Android Studio, have really good Firebase integration. Clicking that usually opens up an assistant panel.
Like a guide.
Exactly. A panel that guides you through connecting your app project to a Firebase project in the cloud.
And the document mentions choosing real-time database Java specifically. So it's focused on Android with Java here. And this assistant helps with setup, gives code examples.
Yeah, the assistant really simplifies things. It shows you the steps, might provide basic code snippets for reading or writing data, and helps configure your project.
Then it talks about connecting to an existing Firebase project or making a new one linked to your Google account.
Right, you need that Firebase project set up in the Firebase console on the web interface. That project is like the container for all your Firebase services, including the database.
Makes sense. Google platform. And once connected, the document says the assistant adds the database to the project and modifies a file called Gradle to add dependencies. What are those for someone maybe newer to Android?
Okay, so Gradle is like the build manager for your Android app. Dependencies are lines in the Gradle file that tell it, hey, we need to include the official Firebase real-time database code library, the SDK, in our app.
So the app knows how to talk Firebase.
Exactly. Without that dependency, your app code wouldn't have the necessary Firebase classes and functions to use.
And it also mentions updating a values file with access keys. Sounds sensitive?
Very sensitive. These keys authenticate your specific app instance to your Firebase project. They shouldn't be shared or hard-coded directly where someone could easily find them. The build tools usually handle them securely.
Good to know. The document also notes you can set up the database directly in the Firebase web console, not just through the IDE assistant.
Yeah, the Firebase console is the main web dashboard. You can do everything there, create the database, manage security rules, even browse the data visually. Sometimes it's easier to do initial setup there.
And it mentions setting up in test mode initially. Open read and write access for anyone. Convenient for starting, but A big security warning sign, right?
Huge warning sign. Test mode is only for the very beginning of development, just to get things working without worrying about security immediately.
But before you go live,
Before you even think about releasing, you must replace those test rules with proper security rules in the Firebase console. Rules that define exactly who can read and write what data. Otherwise, your database is wide open.
okay, critical point. Now, actually interacting with the data, reading and writing. The document says you use database reference objects from Firebase reference. Sounds like key building blocks in the code.
They are. A database reference points to a specific location in your JSON data tree within Firebase.
Like a path to a file or folder.
Exactly like that. You get a reference to, say, user123 profile, and then you can use that reference to write data there or update it or listen for changes at that specific spot.
And when saving lots of items, like a list of users, the document recommends using clear codes, maybe hash codes or custom IDs. Why is structuring it like that important?
Well, if you just have a big list, finding or updating one specific item can be inefficient. Using unique keys or IDs for each item, like a user ID or a product SKU, lets you directly access that specific item's data using its key.
Makes retrieval faster.
Much faster and cleaner to manage, especially as the data grows. It's like having a well-organized index.
Right. Finally, getting data back in real time. It says you don't poll, you listen. An event triggers when data changes and you get a data snapshot. That's the core real-time magic, isn't it?
That's absolutely it. You attach a listener to a database reference. You tell Firebase, let me know if anything changes here.
And you just wait.
You wait. When data at that location changes, added, updated, deleted Firebase triggers your listener code and hands you a data snapshot.
Which has the new data.
Exactly. The data snapshot contains the current data at that location. Your code then takes that snapshot and updates the app's UI or whatever else it needs to do, reflecting the change almost instantly. It's event-driven.
That's a really helpful walkthrough based on the document. And it's great the author included links for more learning official docs, some Medium articles. We'll definitely put those in the show notes.
Yeah, those are good pointers. The official docs are essential for the deep details, and those articles likely offer practical advice and maybe different perspectives. Always good to read around.
So let's try and wrap this up. What are the main takeaways from this deep dive into remote databases and Firebase based on this source?
I think the big picture is the move away from data being stuck on one device. We need data to follow us, and we need to share it easily.
That's the why.
That's the why. Then we saw the evolution from older server setups, which had that update lag, to real-time solutions.
Firebase.
Like Firebase, which offers this cloud-hosted, automatically syncing database that, simplifies a lot of the back-end work for developers. It makes building those dynamic collaborative apps much more achievable.
Yeah, it really feels like it lowers the barrier to creating apps that feel instantly connected and shared.
Definitely. And that leads to maybe a final thought for our listeners to chew on.
Go for it.
Considering how tools like Firebase make setting up a real-time shared database relatively straightforward now, what kinds of new applications or maybe new features in existing apps does that unlock? Things that might have seemed too complex before. Think about your own field, your own interests. Are there ways this kind of instant data sharing could create something really cool or useful that wasn't practical previously? Something to think about.